All right, let's finish up chapter 5, which was all about trusses, and then we talked about frames a little bit as well. And now we're going to talk about machines. And in this case, when we talk about machines, we don't mean like complex stuff like an internal combustion engine or something like that. We mean simple machines, like stuff that the Egyptians used to build pyramids, that kind of level, right? So, and we talked about some of these already a little bit, right? So one that we've looked at a little bit is the inclined plane, right? So basically we have some kind of surface, and we're using that to lift some object upward. Right? So I have this object here, and instead of just taking it and lifting it up, I'm slowly pushing it up some kind of a ramp. And of course, we now know, right, that means that my weight would be going straight downward, but I'm pushing at this angle, like, towards like along the plane. So that means if I break this apart, right, then instead of having to lift the entire weight, I only have to kind of overcome this and some friction, right? So it's a lot easier to get heavy objects like lifted up that way than by just straight up lifting them. Also, from just directly like a human ergonomic standpoint, it's a lot easier to push against something than to lift something up, right? So that's another reason why that was used for a very long time. Another system we already looked at are pulleys, right? What's a pulley? I don't know, pulleys, I guess. Right, the idea there again was that I have a rope that goes over several rollers and then connects to an object, right? So if we say this is some kind of ceiling or something, I have two rollers connected to the ceiling, and then maybe I just have a single down here. No, I need more than one, otherwise it won't work. There, let's do another up there. This is some kind of a block that has a weight, of course. Then I have a rope, goes up and over and over and over. And well, I guess here it can just go up into the wall. We don't really need this last roller. Um, and again, the idea there was right. So if I now pull on this rope here, then I need a lot less force than if I'm lifting this up just by itself, right? Because we found that if we do a free body diagram of this, right, we know that the tension inside that rope is the same everywhere, right? So I have my one roller here, tension, tension, and I have my second roller over here, tension, tension, right? And I have my weight going downward. That means my tension is going to be 1/4 of the weight. That's really helpful if you want to lift heavy stuff. One that we haven't looked at directly as a machine, we have used it as a support reaction, but like a roller, right? So if I have a surface and I want to move a heavy box along my surface, right, then we'll see at the very end of the semester that obviously there's friction, so I'm going to need all kinds of force to push it. But if instead I have a bunch of rollers, then it's a lot easier to push it because now I only have the friction that I get between the rollers and the floor and the roller and my object, right? So it's a lot easier to move something along. Again, if you think about Egyptians, right, or even medieval Europe or something, right, you will have big logs that has the big heavy weight on, and then we can push them along. Doesn't mean it's easy to move necessarily, right? But it's easier. That's always what we're going for. Another important one is the lever, and that's probably something you're using every now and then, probably maybe without noticing. But let's say I have some kind of a weight that I want to lift, right? So what I can do is I can put my little bar under here, all right, and I have maybe some other object that I can set it on, and then if I push down here, then I can lift it up, right? Now this one is kind of halfway, so it doesn't really help all that much. Let's move this one down a little bit. Right, so if I had my pivot somewhere down here, right, then I would get a lot more, right? You can make a simple moment balance basically, right? You could say, well, I know that this distance and that distance would go into the moment, right? So my weight times that has to be equal to my force pushing down with that. That's bigger. So the force that I need to lift something up is a lot smaller, right? So that's what we use levers for. And another one that's doesn't really 100% fit in here, or at least doesn't fit into kind of the idea of the ancient Egyptians using it. That would be gears, right? We can use gears to kind of have one rotation be translated into another rotation. I'm not going to try and draw, well, I'll try and draw some gears, right? So we have something like this, and then another set of gears like that, and then they interact with each other. If we think about this, like simplified as just two two circles, right? Always good in engineering to simplify stuff, right? Then we can say that they're kind of contacting here. So if one is pushing down, the other one has to be pushing up. So if I pull those apart and kind of do it the same way that we did with frames and kind of think about that as a pin, right? Then I can say like, well, if I have a moment on one of these, then that's the same as having a force on the outside. Well, if the force is going down there, has to go up there, and that way I can make calculations, right? Gears are what we usually use gears for is changing the amount of torque that we can put on something, right? So if I have a small gear, right, then the force that I'm pushing on it, right, will make a small torque. If I have a large gear, right, I'm pushing farther away on the outside of my gear teeth, and so there's going to be more of a torque on or more of a moment on the center of my gear. What else do we have? We have wedges, not wedgies, but wedges, right? And the idea behind a wedge is similar to an inclined plane, but on the inclined plane, I have the object moving, and with a wedge, the wedge is moving, right? So let's say I have another big object that I want to lift up, right? Well, I can put something underneath here, right? That has kind of a slope to it. Then I can push this in. That means that block is going to be lifted up, and it's going to be easier for me to lift that block that way than to have to pull the full weight because I'm only putting part of this up. Now these wedges we're going to look at a lot more detail when we get to friction at the end of the semester, so I'm not going to go more here. The other thing that we're going to look at some detail are screws, right? How do the forces act on a screw? So we'll talk about that as well. And with that, we're done with our section on trusses and frames and machines. Remember, like the idea behind the truss was that we have a whole bunch of rigid pieces that are put together, held together by joints, and forces only act at the joints, which means that all those pieces are true force members, and that makes my calculations easier. Frames were slightly different because now we're allowing forces also or loads also to be acting like along the members, not just at the joints. That makes calculations differently. We talked about collapsible versus non-collapsible, and then to finish off today, we talked a little bit here in this one about simple machines. And with that, we are done. And next up will be a chapter on centroids.